Okay, so after recording, so again, welcome everyone. And while we, let people join, we usually start. So the format of the meetup is always that, we pick a concept that we're going to talk about, which today is stacks and queues. And we start the session off with, having this just brief overview about that concept. It's not going to be in depth, just kind of touching point on things you would need, okay, as related to maybe technical interview or generally in life, and then there are always resources for you, even if you want to read up on your own or to know more about it. And after that, we go into breakout rooms, where the breakout room is always divided into, the beginners, intermediates, beginner for if you are very comfortable with easy questions, but you are not yet, confident enough to solve medium questions, because that's what intermediate room is for. So in the intermediate room, they solve medium to hard questions in lit code. Yeah, that's the, that's the range, or that's what we used to measure it. So if you can solve easy question and you're confident and you are still, okay with easy questions, there is the beginner room and then intermediate room for medium to hard questions. So that's always the bulk of the meetup. And I'm just going to take like 20 minutes to kind of, give a brief overview of this concept. Kind of it's more like a refresher course or a crash course, just to refresh your minds, right? So I'm going to, get started with stacks and queues. And let me do this. Okay, so like I said again, welcome. And today we're talking about stacks, we're talking about queues. Both of them are quite similar in the sense that, they help you with, they call them linear data structures, same thing with arrays, same thing with linked lists. But for these ones, they are kind of more useful when it comes to ordering, like when it comes to you're more particular about the order of something, or you want to make use of the order. So that's when stacks and queues comes into play. And that's why they're kind of always grouped together, because it's just, they do kind of similar things, but their order is always in different directions, which we're going to talk about. So unfortunately, I'll be starting with queues. And when you say what are queues, so like I said earlier, these things are majorly for dealing with arrangement, dealing with order, dealing with maybe direction, more order, how things come in and how things are going out. So for queues, it's more like first in, first out. The first element to get to the data structure is the first element that's going to go out of the data structure. Sorry. Oh, okay, Annalisa, that's fine. Don't worry, you can always meet us along the way, and we always record this part of the section, so you'll be able to catch up with it. Okay, so I think she dropped off right. So back to what I was saying. So this queues are making use of, or they kind of, deal with your elements or work with your elements in an order of first in, first out. So the way it came in is the way it's processed. So example is people on the queue, like if you go to a movie theater or you go to a restaurant where you have to queue up, and that's like so common in Vancouver where I'm in. I don't know why people have to queue up to be able to get food. So you are kind of processed in the way you came in. It's the first person that got to the line that is going to like be answered first, or the next person. It's more or less like there is no random order to it, and there is no kind of, so just nobody just randomly picks people and all that. It's just processing a particular order. That's the major thing. And there's the term called enqueuing, which means adding elements to the back of the queue, and another term called dequeuing, which means removing elements. which means removing elements from the front of the queue. So in a queue, elements are kind of added at the back, just the way you queue in a restaurant, or you queue in a line where we have to process something, you want to get something from someone, you guys have to queue, you kind of join at the back, right? And then people are processed from the front. So that's just the same way it is. It's just that when you're adding, it's called enqueuing, and when you're removing, it's called dequeuing from the front. So meaning that you had at one end and remove at the other end. And then when it comes to queue, there are like normal current applications. So the way currently, what concept is queue used in, because sometimes it's always like, oh, these data structures we are learning actually, do we even use it in real life? Do we even use it when we actually, working? Do you actually even use it when you are programming? It's like, they just like to stress us with. Yeah, I agree on one hand that they like to stress us with just learning and grinding these little code questions up and down. But truth be told, most of the concepts you get to learn while doing this, they kind of apply to real life. They apply to your normal day-to-day job sometimes. And that's why they want you to kind of, it's part of like the concept, or it's part of what they judge you on, right? So currently in current applications, when it comes to, the way printers processes jobs, I don't know if you've used a particular printer before that a lot of people have to use, where you send, something to the printer. We currently use it, and that's so people send things to the printer, and the way it processes it is the first job that arrives is the first job that's going to be printed first. So that is one application of where queues are used. Also, when it comes to processing requests, even in your web servers, like from your browser right now, you are sending requests. When you are sending something, you are searching for something, you click on a particular thing, or you fill a form, all those kind of things, you are either sending requests or getting requests from a particular server when you are dealing with your browsers, or when you're dealing with anything, and when you're dealing with, majorly, sending something from your browsers. So you are sending requests, receiving requests. So when it comes to sending that request and saying, oh, I want to get this data, or like, okay, I search for so person, or like maybe you get to a form, you see list of names, and you click on a particular name saying, get me the full profile of this person. That's a request, right? And when you send it to web server, there are a lot of 1,000,001 people probably send a request to that server also. So it processes it, first come, first serve. And that is why you see that button rolling in front of your screen and saying, okay, it's searching, something. You see it on your browser, keep rolling and rolling. What it's doing is that it's waiting for its request to kind of be answered, or something like, if you don't have network issues. So also another application is CPU scheduling, where processes, the way processes are being made to the CPU, same way like request, the way you handle like web servers handle your request. So same way when you are doing anything in your system, or majorly you are dealing with processors. So your CPU has kind of limited capacity, and when you send too many processes, you are doing too many things at a time. You are opening Visual Studio, opening your browser, opening command line, opening every single thing, and it becomes too much for the CPU to handle. All it just does is queue all the remaining processes. All the remaining processes are put in a queue, and when it finishes opening up your browser, then it knows that, okay, you said you're opening Visual Studio next, and then it opens this one. So it doesn't overkill itself. And same thing when it comes to this, same thing when it comes to, so what I mean by process synchronization is related to something like concurrent programming, like too many things are kind of doing a particular thing at a time. Like, okay, too many processes are kind of, having to take data or return data to a particular source, to a particular thing. So at that point, you don't want to undo like different things. You don't want to undo chaos, because it becomes like it becomes stressful when too many things are kind of changing a particular thing at the same time, more or less like maybe a database, right? So too many people can be having to change that database at the same time. So it has to kind of process whatever request when it comes to changing that database in a particular order so that things don't happen, right? And yeah, and more examples. So when it comes to how you can use them, like when you are either dealing with technical interviews or even normal day-to-day life, right? So when you see any question that has to do with maintaining order, right? Okay, when it comes to, they give you a particular question, because like I mentioned last week, when it comes to hash tables, even in stacks and queue, most data structures, when they give you an interview question, they don't tell you that, hey, you're supposed to use queues here, or hey, you're supposed to use stacks here, except if it's like written in the question, something like a min stack problem. Now, you know that, okay, that sounds like a stack issue. But sometimes you're given a question and they don't tell you you're supposed to use queues, you're supposed to use stacks. Nobody's going to tell you. So it is your duty to figure out, does this look like something I can use queues for? Does this look like something I can use stacks for? So when you see a question and it's like you have to process something in a particular order, especially when it comes to the way something came in is the way you have to process it, then that deals with, that's seeming like your mind begins to go through, okay, can I use a queue for this? And that comes to what's called breadth first search. That's, a particular searching method when it comes to trees, and we're going to deal with trees later down the line if this continues, if people keep showing up, So trees, there's a way we have like binary, there are different types of trees, and when it comes to processing, the nodes in a trace, you have to search through them, right? So there are different ways you can search through them, and one of those ways is breadth first search. When you're searching through each height, you're searching them like level by level, right? That is one way queues are very useful, because you just kind of put all this first level in a queue, second level in a queue, that kind of thing, and it kind of processes one by one. And then in concurrent programming, like I mentioned earlier, then another important thing is we have different types of queues. So that is another thing you need to know, and that is another thing you need to put in your mind when you are going for your interviews and even in your day-to-day life. We have the simple queue. That's what I've talked about earlier. Most queues follow the same pattern, right? But they have different ways in which they maintain the order. Now, circular queue is almost the same thing like a simple queue. The difference between simple and circular queue is that, so now, in a simple queue, normally, let's assume you have limited space, and which is normal. I mean, your memory is limited. The size of your computer memory is a particular number. So it's going to finish at a particular point. So if you keep adding things to your queue, or you get to a point where you get to the end of the queue, right? And what happens where you get to the end of the queue, but you've been able to remove from the front of the queue and the queue wasn't moving? Like, in normal day-to-day life, right? When people come into the queue, as people are being removed from the front of the queue, you guys keep moving, you keep moving forward. Like people keep moving forward to just fill in the space. So, but in a normal implementation of a queue, like if you are using a list or something, so when people are getting to the queue, even if people are being removed from the front of the queue may not move, the numbers may not move, because there's no, except if there's an underground process that is moving them. So they're just going to stay there. So if people were maybe at position, if the queue stopped at position, let's say 9 or something, and we already had 9 people coming to the queue, right? Even if they have removed person 1, person 2, person 3, the queue had already stopped at 9. It's not going to move every other person forward like we do normal day-to-day life until there's a particular process that does that. And that is why we use what is called circular queue. So circular queue deals with that problem of, instead of having a particular underground process that moves people inside the queue, like move people forward like we have day-to-day life, that, when you remove person 1, person 2, like person 3, 4 should move to the front, right? So instead of having that process that moves to the remaining people, you just make use of a circular queue such that even if you get to the end of the queue, so when you get to 9, right, you just have the queue starting again at that kind of 9. So how would I put it now? So it's not going to be something like, okay, when you remove person 1, person 2, or person kind of 3 from the queue, I'm not explaining it well. So kind of the queue is just a kind of, it's round, let's put it like that. Yeah. So let's assume people are queuing kind of in a round, or like kind of a roundabout something. So as people are moving, even if people don't get to move, right, the queue can come back to the starting point and start filling up people again. So that's like what I'm just trying to say. So just like you have here. So, and which is most likely what what is the inbuilt queue that you see in your languages, in the languages you use. You mostly see something called circular queue, because it just doesn't have to worry about space. It doesn't have to worry about like you filling up or getting to the end of the queue, and we are not able to make use of what spaces at the front or something like that. But yeah, that's something to read up on. I'm probably not explaining it well. I added resources where you can read more on it. Priority queue also, and something called double-ended queue, where you remove and add from one end and also remove and add from the other end, like same thing. And yeah, that's that about queues. Now coming to stack. Stack is almost similar like queue, like I said earlier, in sense of it's still dealing with order, but the difference between this one is that you don't process first in, first out. It's more or less like last in, first out. So the last person that got to the list, or the last person that got to the data structure, the storage place, is the first person that is going to get out. So example is like your stack of books or stack of plates. If you want to wash a plate and you stack them together, is the last plate that is on top that you're going to pick first and wash, right? So that's the way a stack is. And for this one, you push and add to the element from the top of the stack. So meaning that you are adding and removing from a particular point from one end, which is most likely always the top. So you push to add elements at the top with operation called push, and pop is what you use to remove elements at the top of the stack. So the operations here are push and pop, unlike in queues that it's called NQ and DQ. And oh no, this was supposed to be called stack usage. sorry, that's a mistake on my end. So stack usage, current applications, just like one current application in normal real life is like your back buttons, when you click on back in your browser. So your browser kind of uses stack to keep track of the sessions or the pages you viewed before, so that once you click on back, it just goes to the top of the stack and picks the last page you viewed, right? Since it is, last in, first out. So the last page you viewed is the first thing you see when you click on back. So that's one important application. Then another application is something called call stack. So in your functions or in your normal, the way your programs work is that when you call a function, and in that function, you call another function, and inside that other function, you call another function. You make use of stack to keep track of the functions you've called, so that when you are returning, it is that we are returning to the right function, that called it. So let's say A called B, and inside of B function, you call C, and inside of C function, you call D. When D returns, it should return to C, right? And C should return to B, and B should return back to A. And that is why when you use them is recursion. So, and a very common, algorithm we use a lot of time is recursion. When we say a question and you either see that the question is going in branches, the first thing that comes to your mind is recursion, right? So sometimes instead of using recursion, you can just use a stack, because it's similar, it's the same thing, and it's literally the same space complexity they use. So that's because when I was mentioning function call stack, what would have been coming to your mind is something like that recursion. In a recursion, you are calling the function inside a function inside a function. That's exactly what you're doing. So sometimes when you are to use recursion, instead of using recursion, you can even use a stack. And another place is depth first search. I mentioned breadth first search for queues. So for stacks, if you are trying to search deeply, you can use depth first search. That's when you get to tree. But it's important to just know that when you get to trees, there's something called depth first search where you use a stack, and breadth first search where you use a queue. And again, this was supposed to be called stack usage, not queue usage. Sorry for that. I should even adjust it. Let me do that now so that I just stop confusing people. I'm coming, sorry. Yeah. So stack usage. Yep. Okay. Okay, and okay, so moving on, and another place is reversing. When you have to reverse a list of elements, you have to reverse an array or reverse something. And okay, I was going to mention something, but I think that's going to be nesting. So it's you can also use them when it comes to reversing. You can use them to pass strings. You can use them to evaluate expressions. Those are places where you can use them, right? When you see questions that are related to something like this, what can begin to come to your mind is stack, right? And then things to note. Yeah, that's what I was going to mention. So I'm going to jump quickly. Okay, space complexity is even the first thing. So the one thing you need to know is when you're using queues or you're using stack, most times your space complexity is order of n. Like it can increase and it can reduce, but like most times, because what happens is that you are keeping track of all elements. So always put that at the back of your mind that once you are using a stack or you're using a queue, you are using additional storage already. So when you have a question that says, oh, do not use additional storage, and your mind is thinking of stacks and queues, please take that into consideration that stack and queues uses additional space. So yeah, you may need to know what to do when your question is saying don't use additional space. So that was the point I wanted to mention when I say you can use it to reverse strings, you can use it to reverse elements. So it is good for reversing elements, but you should note that when they say do not use additional space, you can't use it, right? And another thing to note is the time complexity when you're inserting and deleting. So when you're removing or adding either enqueue, dequeue, push, pop as in stack, and queues, it is always order of one. So that's why it is very good when you have to maintain order, and all you have to deal with is just how you add something and how you remove something. So if that is what is on the mind, then you can think about, do I use stack or do I use queue? When you don't have to worry about any other elements, just what is added, what is removed. And because when you are visiting every element, when you have to like maybe iterate through the stack or iterate through the queue, it is no longer constant operation. It is already like order of n. So yeah. And also another important thing is knowing how they are implemented. It is not compulsory, right? It is not mandatory, but it is important because it's going to help you learn more about what it is like, especially when it comes to queue. It helps you to know the different types of queue. It helps you to know how they operate, and you don't be like me and not know how to explain a secular queue, So it is important to know how they work, because again, I mentioned it last week, you never can tell how your interview can go. There are different types of interview. People have attended an interview before where we didn't solve any question. All we were just talking about is data structures. And the person was just giving me, okay, what is a queue? Can you explain how they work? Okay, what is a tree? Can you explain that? That was my interview. So you never can tell. So it's important to know how these things work. And one way you can know how it works is by implementing them. And also know the common impressions, know what it means in whatever language you're using, and know how you can do that. The worst nightmare is for you to go to an interview and you say you're using Python and you forget what way it is to add elements to a stack, or what the enqueue function is called, or how it looks like, So it's important to know that, know how to add an element, to queue stack, how to remove an element, and how to check if it is empty. All these things, they're already inbuilt into whatever language you want to use. So even if you're using a stack or a push or a queue, you are most likely going to be using the inbuilt one that is in that language you're using. So it's important to know how to call this things. Is it called is empty, or is it just called .empty? You don't want to go to that interview and just be like, is it called is empty? Is it called empty? Sorry, please, can I check online if it's called? Anyway, you can try. Nobody's going to, tell you that, no, don't do that. But it's just important for you to know how it is. It's kind of lets us know that you know your language very well, right? And then how to check if it's full, and also peak, important. Peak is just more or less like you are looking at, when it comes to a stack, you are looking at the top of the stack, but you don't want to remove, right? You just want to look at what is on top. And that's important if you probably want to compare, because again, you can't search through, right? You can't say, oh, I want to search for something, but you can say, oh, what is on top? So I want to know, do I push something additional up to it, or do I just remove it? So let's say I want to compare, if a bracket is the same with another bracket, and I will always want to check the stack first to know if it's the same. If it's not the same, I push it. If it's the same, I don't push. So all those kind of things. So this peak is super important. And even in queues, I think there's something called peak where you can check what is in front also. So those operations are important. And that comes to the end of this quick overview. Again, I didn't go in depth, and I probably didn't explain well. I didn't explain what a circular queue is. So you really need to read yourself and read on your own. So we are going to be going to breakout room now. And one, I want you to remember that we talked about this problem solving process in our very first meetup. So because the breakout room is for you to serve as a kind of a practice place. It's for you to see how every other person sees, this question. How does every other person approach this question? So it's like you coming to learn from every other person, not just the facilitator in the room, right? And you yourself opening up yourself to that learning. So don't go there and just stay mute, or, stay non-interactive like you are right now. Go there and open up yourself, interact, talk, explain your process, explain what you are thinking, also listen to other people. We are all here to learn from each other. So if everybody's going there and going to stay muted, who are you learning from? And nobody's learning from you too. So that is why you should go there, and everybody should open up so that we can all learn from each other. People's thinking process are different from yours, and it's important to know how other people approach problems to see whether you can learn a thing or two from it. And you also have to do that so that somebody else can learn a thing or two from you. So it is a give and take here, right? So that's why I'm encouraging you to interact. And, this is one way you can do that. You have the question, we have questions you're going to solve. You go through the process of repeating the problem, try to see if you understand the question, ask questions, give examples, then solve, brute force, optimize, implement, then you test. And that brings us to our breakout rooms. So I'm supposed to have done that. I'm going to create the breakout rooms now. And what I'm going to do is call the breakout rooms these names. I have 3 breakout rooms. And you get to choose the breakout room you're going to. I may reassign later, but just to allow people to pick whether they are beginners, like whether they want to go to the beginner room or you want to go to the intermediate room, right? Because we can't kind of be asking people right now. That is not efficient. We are all about efficiency in this place. So I am opening the rooms right now. And okay, sorry, I forgot to ask if you have any question based on what I've said before, please feel free to say that, or feel free to unmute your mic, drop it on the chat. I'm sorry, I didn't say that. So do you have any questions of what I've said so far, either talking about stacks, talking about queues, or you want to ask any general question about this whole program, this meetup, the series, the breakout room, while I'm creating breakout room? Sorry. So if you have any question. And also another thing to point, so I've opened all rooms, I guess. Okay. So another thing to point, and in your breakout rooms for beginner room 1, this your facilitator is Fumi. Beginner room 2, your facilitator is Timmy. Let me check if they are here. And intermediate room, your facilitator is Tunde. So these are your facilitators, but they are not here to teach. They are here to guide you. So please open up yourself. And another thing I wanted to mention is that we have a repository we used to keep track of the series. So in case if you missed any sessions before, or you want to just, remember something that was talked about today, and most importantly, checking resources. So we already have stacks and queues here, and we have tons of resources for you. Aside from the questions you're going to solve in breakout rooms, there are other questions you can use to learn more about this. So check the resources, very important to read more and learn more about it. And the questions, please solve them. It's going to help you. And even if you don't solve every single thing, anyone you solve, we encourage you to please send a pull request. So this repository is open, it's open source. Feel free to fork it, clone it, add your problem, your practice solution to this place, and then send us a PR. Just like I said, we are here to learn a thing or two from each other. It helps people to also learn from you, learn how you're able to solve a problem. And you can also see how other people, approach a particular problem, because there is no one way to a particular market. There are several ways to be able to get to a particular place. People have been sending their solutions. We have solutions for strings and arrays from several people right now. So add your solutions. It helps people to learn. It helps you yourself to also learn. Keeps you accountable. That's one thing I wanted to mention. So now I've opened up the breakout rooms, and you can join the breakout rooms based on your level of comfortability, if that is an English, I don't know. So whatever level you're comfortable with, please join the breakout room. Let me assign the facilitators to the right room. Okay. Okay, your facilitators have joined now, so I think you can join the rooms. Let me see if the other facilitators join. I'm going to pause the recording also. So if you're going to be watching the recording later, people are going to breakout rooms right now. And we don't record breakout rooms just to allow people to have that freedom and make it an open space for people to be able to learn and not feel being judged or something. So I'm sorry, we don't record breakout room, but majorly they're just going to be solving these questions that we have here. So feel free to always check the repository to see, how those questions were. So we always had the questions back there. So I'm going to pause the recording and this. Oh, you're enjoying it. Sorry. Come back next time. So for those that have been listening to the recording, we are back from the breakout rooms. And as usual, like I said, we don't record breakout rooms. And yes, they did enjoy their breakout room. Oh, man, she said that was a good session. So just like you're saying, that was a good session. Just like you're saying, you enjoyed it. Please feel free to give us your feedback. And most importantly, tell us what we can improve, apart from giving more time. We can't give more time. I can't do that. I mean, I don't want to make this 3 hours. No, that's gonna be bad. So please, apart from giving more time, tell us what we can improve, give us feedback, super important. And just before we end for the day, I need to call out that please, we have resources for you to read more on the concept talked about today. Not even just today, they have been we've been able to keep track of other sessions we've had in the past. This is like the 4th one we have in. So if you want to read up or check through, catch up or anything, even if it's later on, like if you feel you have an interview coming later on and you want to always look for something that is kind of a bit structured, not organized, but at least that can help with pointing you out in the right direction, you can always come back here. And more importantly, for your sake and for others, please add your practice solutions here. Even if you feel like someone is not going to learn from it, even for your own sake, just add it here. You never can tell when you may need this another time, and you just want the place where your own personal solutions were. I know LeetCode keeps track of that, but yeah, you can always ask questions in the Slack group, even though you people don't ask questions. So I just assume that, people are always okay enough after orders, and they are always like, yeah, we don't want to ask questions. Or you just feel like people don't ask questions too. So you are not going to ask questions. Be the first person, right? So ask questions on the Slack group chat. People are there to listen to you or answer you. So ask your questions, please. Make it interactive. People want to learn from you. I always say, so I want to drop the link to the Slack right now. Am I? Okay. So when you join the Slack, make sure you join this channel. That's the channel where you can, ask your questions and you can find people to answer you. You can't. Can other people hear me? Okay, blessing. I think it's just, oh no, I didn't copy it, sorry. Blessing, I think it's just you that can hear me. I want to copy the link. Wow, this is not copying for me. Why? Copy. It's not copying the link. I'm coming. Let me reload it. Okay, so I will try and drop the Slack channel link. Don't know why it's not copying the link for me. Chat. Okay, yeah, I'm able to copy the link now. Okay, so that's the Slack channel. So please ask your questions, drop anything, even if you're not asking a question, even if it's just to say, hey, I just finished solving this question. Did anybody just solve the question too? And you just want to bounce ideas, just drop anything, anything. So, and please send us your PR with your solutions. If you're having issues of sending the PR, or you can ask it on the Slack channel too. You can say, hey, I just finished solving these questions, but I can't send the PR for it. PR pull request. So I need someone who can help me. People are always willing to help. That's just one thing you need to know. Don't feel shy to ask your questions, thinking people are going to think that you don't know anything or something. Please ask your questions. Ask your question, importantly. So yeah, that's all I have for today. And our next session is going to be coming up in the next 1 month. So I'm sorry, we're going to take a break. We won't have any session by May 14. Yeah, I know. I'm so sorry. So we are going to take a break, and next session is going to be May 28th. And as usual, I will drop it on the Slack channel saying, okay, please RSVP so that you can get the link. We're going to be talking about sorting and searching, and it's always very common. It's a very common topic in almost every interview you'll have. So, and you can always read ahead. I know it's a long period, but again, you have as much questions to solve before that time. You can always still ask your questions on the Slack channel. You can find people on Slack channel that you can just brainstorm ideas together, and just, you can just have meeting with anybody there and just solve any question together with anyone. So feel free to do whatever you want to do. So, but yeah, unfortunately, we have to meet in the next 1 month. I'm sorry for that, but that's where we are at. So with that, that's the end of today's session. And yeah, we did it again. I'm so happy you guys stayed to the end. And I look forward to seeing you in the next session again. Hopefully you come back. Let me add the Slack link again, Blessing. Yeah, this is Slack link. So hopefully you come back in the next session. I'm open to see the names I'm seeing right now. I can see your faces. I can see your names. Hopefully I see you again May 28th. So that's it. If you have any questions, let me know. Else, we've come to the end of the session, so feel free to drop.
All right, thanks a lot.
You're welcome.
Yeah.
Thank you.